Hello guys, it's Rafi, and today we are going to see how we can create a data pipeline using Kafka and Kafka connectors. Let's see. So what exactly is a data streaming system and why do we want to have it established? Based on the business that you're currently working with, there might be several use cases applicable to your company. For one thing, you can consider generating informative reports for the business part, or maybe just providing it for the customer or whatever, doesn't really matter. But whenever it comes to data and you have massive amount of data stored in one place or many places, and you want to perform some query over that just to provide enough information, or let's say more valuable information out of these raw data, this system comes handy. For one thing, imagine that you have many customers for your company. Each customer has separated database and you just store lots of data relating to the customers in their dedicated database. Now company wants to create new policies, maybe some new marketing strategies or something like that. And you need to know how exactly your customers are using the system and what options do you have to increase the performance maybe, or just providing the customers with more beneficial programs or offers or so on and so forth. For that case, you need to perform specific queries over all the stored data. But the point is, like, those kind of queries all the time are super complex, and most of the time they just impose lots of load, lots of pressure on the database, and it might affect the performance of the whole system. And on the other hand, it might be time-taking process, and more importantly, most of the time this kind of architecture won't be a real time, right? So having a data streaming system just empower you to have a real-time reporting and use dedicated tools to perform those kind of queries. So instead of just running those kind of queries over databases one by one and then just thinking about how exactly can we aggregate all of data and so on and so forth, you shall have all those data transferred to a data warehouse for one thing, and have your ETLs, have your queries run on that data warehouse, and then you can generate reports. So basically, you transfer all those data to a dedicated system for this scenario, which is data warehouses. So in general, in a nutshell, a data streaming system is a system that enables you to stream data stored in one source or many sources to another destination. So this is the whole concept that we are going to cover it. For this video, the approach that we are going through is just like leveraging all the benefits that Kafka will provide us with, and then leverage these benefits in a way that we can have all those data transferred to the destination in real time. So for grasping a better idea of what exactly are we talking about right now, let's see some of my beautiful drawings. Okay, let's go into it. So imagine that you want to establish a data streaming system. What would be the components of this data streaming? Let's call it like data streaming system. So what exactly would be the components of this data streaming system? As mentioned, you shall have one Kafka cluster here. You have some, let's say, I will just create it as a group, right? I will say group of sources, right? Like DB1, DB2, and so on and so forth. On the other hand, for transferring all those data stored in these databases and group of the sources, let's call it group of sources, to Kafka, you need to have another component designed for this specific purpose. This component's name Kafka connector, right? We will just describe the whole process. The only part that's basically we won't focus on is Kafka itself, because Kafka deserves a separated video. It's a big topic. It has so many different configurations, and for grasping enough knowledge to work with it confidently, we need to cover it in a separated video, or basically this video gonna take too long. So the mechanism is just like this. Kafka connectors start talking with this group of sources, different databases, and then from here they basically get the results. Imagine that it can be just simple as like select queries, and here is the response, and then later, based on whatever it gets from the source of the databases, it will start talking with Kafka and store things in Kafka. So this is the whole process. From here on, basically, you can again use Kafka connector to connect it to different sinks. Imagine, like, I will just name it group of sinks. One of them might be BigQuery, another one might be Mongo, or whatever, doesn't really matter. But as soon as the data is placed in the Kafka, you can use the same mechanism, right? So another part of Kafka connector can just read all the data stored in the Kafka and then send them to the targets. So following this process, you shall stream all the data in group of sources into Kafka and from Kafka into the sinks. So we just named two specific keywords here, sources and sink. That's the exact concept of the Kafka connectors as well. So Kafka connectors are basically with two types, source connectors and sink connectors. Source connectors basically are responsible to fetch data from databases and send them to the Kafka, and the sink connectors are basically responsible to fetch data from Kafka and send it wherever you want to have it, right? So this is two types of connectors we have. So what exactly is Kafka Connect? Kafka Connect is a component that can act as a cluster, and it can run different tasks on it, right? And those tasks are basically the tasks that are responsible for fetching data from sources, right? So when we say we can have it as a cluster, that means that you can have more than one instance of Kafka connector and just form a cluster of those, different nodes, different pods, depends on the implementation mechanism that you want to go with. These Kafka nodes, it starts syncing with each other. They can load balancing. So for example, if one of the nodes of this Kafka Connect cluster is overloaded already, the new task might be transferred to the new node, and so on and so forth. All those things, all these concepts that you basically have in the concept of any cluster. So the part that we are going to cover in this video is this scenario. Our scenario is like we have a Postgres database, right? We have a Kafka cluster. Excuse me. And then we will create this Kafka connector cluster with a specific tiny worker in it for, let's say, Postgres ingestion, and then this gonna fetch things from here and then send it to Kafka. This is the whole concept of this video. So let's see it in action and understand how exactly are we playing with these components, how exactly can we configure them, what is the process of creating the Kafka connector cluster, what is the process of creating the Kafka connector itself, and so on and so forth. Let's see. So all the materials you will need for establishing this system in your local machine or testing environment is already placed in the Github Repository down here, so you can leverage it. And then how exactly it works. In this specific repository, we have a directory, namely lab Kafka Connect. Let me just open it as a VS Code, that might be easier. Okay, very good. Yeah, we have a directory namely lab-kafka connect. Whatever you need to work with is placed already here. We have two directories here, infrastructure and application. So infrastructure is basically whatever that you need as infrastructure. For one thing, there is a Docker Compose file which is responsible to create a, let's say, Postgres database in your local machine as a Docker image, of course. There is a directory namely load generator. So basically we use this very simple Go application to just generate some loads, just connect to the created database, push data into it, and see how exactly Kafka connector just transfer all those data to the Kafka in real time. So this is the load generator, and also you have this specific YAML file for creating the kind cluster. So basically, just like other videos, the solution that we are going to implement is based on the Kubernetes, and we will use kind cluster for our Kubernetes environment. So this is it. Another important thing for bringing up the Kafka and Kafka Connect, of course bringing up Kafka is not covered in this video, but there is already another video for it in the channel. You can see it, but we basically use Kubernetes operator, and one of the best Kubernetes operator for just playing with these Kafka components is Strimzi. So you can basically go through the documentation. I will just illustrate whatever feature we use from Strimzi operator, but for full understanding how exactly it is, what options are available, and so on and so forth, you can just check, and you can just give the documented check. So this is it, and also there is a README file here that just guide you through. You can just go through it and just do whatever I did right now at a blink. Very good. So let's start. So the first thing is just like I'm currently in the same repository. The first thing is just creating the Kubernetes cluster itself. Let's have it created using create cluster command. I will just name the cluster like lab-kafka connect, and the config file is basically this file that I mentioned. It's nothing specific, just bring up a Kubernetes cluster with 2 workers, and that it is, nothing more. So let's have it created. Okay, now that we have the cluster created, the first step again is just by installing Argo CD. It's my personal preferences. Of course, you can just apply whatever that we do with this Argo CD using Helm install if you prefer like that. But my personal opinion is just like if you already have a CD based on GitOps, you should leverage it. And I would go with that approach all the time. Just find it more convenient for myself. So let's install, let's say, install Argo CD. And if you don't know how exactly can we just have Argo CD installed in this cluster and so on and so forth, there is also another video for that. You can just take it covered there, and also all the materials for that part is in the same repository, so you can go through the README files and so on and so forth. So let's create the namespace first and then install it. Okay, cool. So let's see the initial password that we need to use for Argo CD. Very good. Now let's form a very simple port forwarding to access the Argo CD. Forward Argo CD looks good. Okay, we don't need you anymore. Just come here and then so the username of course is admin, the password is whatever we got here. So because I already have all those materials added to the Git, I would rather try to add the repository right now. So what is the address of the repository? Let me just quickly grab it. So code, I would go for the HTTPS form because it's a public repository. So the project default, there you go. Okay, cool, we have it. So now the only thing that you have to do is just by adding the first Strimzi operator. So a Strimzi operator is basically a Kubernetes operator created and developed by Strimzi team, which is responsible to handle all these complex maintenance manual works for establishing a Kafka cluster, Kafka Connect, or other components related to Kafka. We use this because first, it's going to be a Kubernetes native way. Second, most of tricky manual jobs will be handled by this operator. So for example, if you want to scale up the Kafka cluster or Kafka Connect cluster, or you want to just add new feature or just bump the version of the Kafka and so on and so forth, all of this can be handled by operator itself. That's the first benefit. So basically, you should not be an admin of the, let's say, Kafka and Kafka system, Kafka ecosystem. That's one benefit. The second benefit is just like you shall have some CRs and CRDs. So basically, it will act based on your CRD, and you can host your CRD in your Git as well. So basically, you have full history of the changes, what happened, what should happen, and so on and so forth. And yeah, I mean, all in all, I find working with this operator super amazing. It just simplifies the whole thingy so much. Big like and big thanks to the team that developed or contributed in developing this operator. But yeah, all in all, we will going to use a Strimzi operator. If you want to see the documentation and go through it, I think the best way is to go through the GitHub page of them, and that's a very good start point. So basically, here, if you see, you shall have even some examples. Let's say here, and then the Helm chart and so on and so forth. And also there are so many links for the official documents, and then you shall find everything you need to working with this specific and beautiful operator here. So we will leverage Helm installation of the operator itself, and we will go with Argo CD approach for that. So basically, we create an Argo CD application which is responsible to install this Helm in the cluster. And from then on, whenever we want to create a Kafka cluster or we want to create a Kafka Connect cluster, we just put some CRs, and the rest is on operator itself. Let's see it in action. So for that part, what we have to do is just like going back to the Argo CD. I will create a new application. I will say Strimzi, let's say operator, maybe. The project gonna be the same. Yeah, create the namespace of course, and then we already have it merged, so head is enough. I mean, you can, if you have it in a specific branch, then I mean you can just change it, but we have it in head. So and the path is just like lab-kafka-connect / so whatever we need to work with is basically, if I'm not mistaken, inside applications. So we don't have anything to do with the infrastructure anymore. I just forgot that we didn't bring up the database, but we will take care of it in a second. So a Strimzi operator. So I will address it. So it's like applications / Strimzi operator. So applications / Strimzi operator. The cluster is going to be the same. The namespace of the application is here, of course. the same namespace of the Argo CD, and that it is. So let's create the application. Okay, cool, and let's have it synced. Okay, so what exactly is going on in this system? First, let's see the components of this Strimzi operator. So you shall see, I mean, these are all the CRDs for creating the Kafka bridge, cruise control, Kafka Connect. I mean, so many things. You can just check it out in the documentation itself. But yeah, the CRDs are here. The part for the operator is coming up. Let's wait for it a bit. And then, yeah, all the cluster roles, role binding, whatever that is required for this specific operator to be functional and be aware of the whole system. So let's see. So one very important thing about this specific installation of the, let's say, Strimzi operator is here. We have only one value overwritten in values file of the Helm Strimzi, and that is like watch any namespace true. So basically I did that because the way that I will implement the Kafka and Kafka Connect is basically I will create a different namespace for it. I will not deploy everything in one namespace. So that's the reason that I have to just turn it to true, because by default it's false, and when it's false, basically it cannot consider all those Kafka clusters or whatever that is placed in another namespace. That's one thing, and by now we should have it up and running. Let's see in a second. Yeah, I mean, yeah, it got halted. So we are good with this part. First part, we need to first bring up a database, because as you can remember, there should be a source. Our source in this video is just like a Postgres database, right? So we will bring up a Kafka Connect very shortly using Strimzi operator again, that is responsible to connect to this specific database and just stream data stored in a specific table from this Postgres to Kafka. That's the whole process of the this video. But for bringing up that, what I gonna do is, where is that? Yeah, let me just open up another one. So inside this structure, I will just increase the font size a bit. So I have a Docker Compose. Okay, I have a Docker Compose file. So what I'm gonna do is like Docker Compose up-t, and yeah, it will just bring up a very simple Postgres database. Let's check it out together what exactly it is, and then you have a better idea. So infrastructure, the Docker Compose. So it's super simple Docker Compose file. It's just like responsible to bring up a Postgres 14 up and running. The port binding is just like this. I mean the default port for the Postgres. I just created a username and password in the default database. I mean, you shall just change it based on your preferences, doesn't really matter. But here is very important part. I mean, I just passed some arguments for running the Postgres, which is like val level logical. So we will get into it very shortly, but basically this is something specific to Postgres. We are talking about Postgres. Postgres has a specific mechanism for just allowing the connector to have all those data streams, and that's like by creating a logical replication slot and vals. So using these write ahead logs, using these val logs, basically connector is able to track whatever has happened to the database and just replicate all those changes, inserts, deletes, updates, or whatever transaction that you already have in the database. It will just stream it, and then the whole mechanism is based on logical replication slot, and that's the reason that we enabled val level. We will take it covered, I mean deeply, but just in minutes. So now that we have the Postgres database up and running, the only thing that we have to do is again creating a new application for the whole ecosystem of Kafka and just address it in the Argo CD. So what exactly it is? We have like Kafka UI tool. It's a very simple tool. It's just like, basically this is not necessary for this specific architecture, but I find it really useful because basically that way you are able to connect to the Kafka clusters created by operator, and you can play with all those configurations and see everything that is happening in those clusters using a UI. And I think that's a real benefit because then you can understand what exactly is happening in the system, if your topic is working, if data are being inserted to the Kafka, and so on and so forth. So this component is something that I just came up with. I mean, this is not necessary, this is not crucial, but it's beneficial. We have a CR for Kafka. I just named it like CR-Kafka. If you go through it and just compare it with the, let's say, documentation of the Strimzi operator itself, basically it will create a CR that a Strimzi operator would understand. And based on the CR that you create here, it will basically create a Kafka cluster and configure it, right? So going just through it, it just targets a specific endpoint, which is like Strimzi.io via beta 2. And then the version of the Kafka, which we went for 3.8 at the time. And then only one replica. I don't want to come up with the, let's say, a high available cluster for this specific video. Of course, in production environment, we want to go with like high available cluster, but for the sake of the time and just simplicity, I will just go with the one replicas. There are some specific configurations here, like replication factor, the default replication factor. Of course, you can overwrite it for every topic individually, but I mean, if you don't just overwrite it explicitly there, then that will be, let's say, the default value. So default replication factor, default topic replication factor, transactions, and so on and so forth. The storage, I will go with like, just a JBOD. I mean, JBOD is something specific for this Strimzi. You can check the documentation for it, but it's basically you could even go with the empty directory. I mean, this is not a production environment. If it's a production environment, then you shall have a dedicated database and play with persistent volume and persistent volume claim, PV and PVCs. But here it is, and then for the Zookeeper, again, we will go with the replicas of one. So again, only one node of the Zookeeper and the same configuration. So all in all, we will just create a very simple Kafka and Zookeeper, right? If you don't know what is Kafka, if you don't know what is Zookeeper, don't worry, because there's going to be another video, if it's not already in the channel, that I will just explain everything about Kafka and Kafka Connect, Kafka and the Zookeeper and how exactly they interact. So this is the CR for the Kafka, and we have another CR for Kafka Connect. Again, for Kafka Connect, I will, because this is the main focus, I will just bring up 3 nodes for Kafka Connect. And then here you have the image. Okay, very cool. What exactly is this image? So basically, Kafka Connect itself is coming up with one main, let's say, process. The process that is responsible to start interacting with the Kafka and also interact with the other Kafka Connect nodes, let's say like this. So the whole concept of the connectors, we can consider it like plugins. So basically every connector that you add to this system, it's a plugin. It's a plugin that is placed to a specific directory, right? So the reason that I address it with, my public and Docker Hub thingy is because I created a Docker file and just placed the Debezium Postgresql Connector. The tar file, the compressed file, just like a package, and just placed it to a specific directory that is understandable for the Kafka connector. So this one is nothing more than the original Kafka Connect image, along with only one added layer, which is copying Postgres connector to slash, I will put the address here, but in the appropriate place. So the bootstrap servers for the Kafka is here. Remember, in the Kafka, where is that? In the Kafka, we just name the Kafka cluster like my cluster, and here you shall see my cluster-kafka-bootstrap export. So basically, this is the service that will be created by the Strimzi operator, and the first part is basically the name of your Kafka cluster. We have also some, let's say, configuration for exposing the metrics of the connector. This will be the topic of the next video. I don't want to combine the monitoring system to this video as well. It's already got too long, but basically all the rest, these things here are only for monitoring, so we can just ignore them for time being. In the next video, we will just cover it full, and you can see how exactly can we monitor the, let's say, Kafka Connect and see everything actually in action. I mean, including the network loads, I mean, inputs, outputs, disks, I/O, everything basically. So this is it. So this is the CR for the Kafka Connect, and at the end of the day, we have only one other CR for Kafka Connector. This associated Kafka Connector is the Debezium Postgresql, and as mentioned, it's already implemented in the image of the Kafka Connect. So all the nodes that are coming up, all those 3 nodes are coming with this specific plugin, so they know it. And I just name it, and yeah, the class is this one, of course, and then the tasks, and then the configuration of the connector itself. Let's go through this part because this is the most important part. The point is like the Debezium connector for PostgreSQL is widely used basically for just transferring data from Postgres to Kafka. It also has a very well-defined and just complete document here. Basically everything related to PostgreSQL connector, you can find it here. There are so many parameters that we cannot cover all of them in this video, but we will just focus on the basics one and the items that we cannot basically skip. But I will put the link for the Debezium PostgreSQL connector here. Give it a check, specifically if you want to use it in production. Of course, you need to understand how exactly it works. But now let's focus on the configurations we have. So, as a matter of the config, we have a topic prefix. So basically, imagine that you have different databases in let's say, one Postgres database, and then you want to just somehow differentiate between, for example, table names in database A and table names again in database B. So this is how exactly you can do that, just adding the topic prefix. So please consider that every tables in Postgres database will be mapped to a specific topic in Kafka, right? You have the flexibility of defining the name of the topic, just like adding some postfix, adding some prefix, and so on and so forth. So basically you can understand what exactly this topic is mapped to. The database hostname, which is my, let's say, interface, I mean local network interface of mine. You need this one because a connector should know where to connect to, and it can gain it using the address and the port. If you are using the production ready PostgreSQL, let's say, component, then you can also use the FQDN, or maybe, I mean, the host address of the PostgreSQL. Okay, which database you should connect to? We will cover it using database name here. So as you can remember here, during the startup process, I already created a database named the default DB, right? It's here. So I just instruct this connector to connect to default DB, and the username and password is the same as already defined in the Docker Compose file. So these are the valid ones. Connector class. This is how exactly Kafka Connect knows which plugin it should call, right? So the whole process is just like this. You will put the connector in the correct place, right? During the boot process of the connector, it will just iterate through all those directories and understand all the classes of the connectors available there. It will memorize it. It will know which actually classes are already available in this Kafka connector. So this name is basically referring to the Debezium, let's say, Kafka connector. Maximum of, let's say, task number, it's 1. You can go through the document, but particularly for PostgreSQL database, not during the snapshotting, that's something else, but for streaming you can have only 1. And the reason is just like because it has to somehow keep track of the progresses using val files, write ahead logs, logs. And if you have more than one basically thread, more than one task, it won't be consistent. So even if you just increase it to 10,000, doesn't really matter. The Debezium Postgresql Connector will come up with only one task. Plugin name, PG out. This is the concept of the Postgres itself. I don't want to cover it, but basically this is the serialization, let's say, model that we use to just replicate all those changes and receive all those changes using the connectors. A slot name. You remember we talked about, let's say, logical replication of slot. So basically this is the process. When you create a connector, when connector actually connects to that database, it will start logical replication slot, right? That logical replication slot using publication, which I will just say it in a moment, but for time being, somehow knows which kind of changes for which tables it should just keep and deliver to some other components, right? So for example, there might be some cases that you want to only stream changes to specific tables, not all the tables. For example, the only important table for you is just like employee or sessions or something like that, doesn't really matter. And then basically you instruct this logical replication slot to only consider insert, delete, update for that particular, let's say, tables, and then deliver it to Kafka Connect. So when you want to create this logical replication slot, you need a name, and this name should be unique across a Postgres database, sorry, right? So this is, let's say, a unique name that's gonna be the name of the replication slot, and the publication name. Okay, so do you remember that I just mentioned that you somehow instruct a specific replication slot which changes for which table should you consider? That's the mechanism of the publication. So basically every replication slot, logical replication slot, should be attached to a specific publication in Postgres, and that publication is the definition of what exactly you should consider. So this is in the publication that you said only table employees for insert and update is important. I don't take care of the delete events, for one thing, or I do want to also replicate the deletes and so on and so forth. But all of these structures, instructions are already placed in the publication. We will create the publication in Postgres very shortly, no worries. And yeah, I mean, the replication shall be a slot. The replication slot here shall be a start by Debezium Postgres itself. So table included. So basically, which tables do you want to ingest? Do you want to create a streamline for? I basically mentioned that whatever that is placed under public schema, so whatever table it is my opinion, is in my interest. Sorry. So incremental snapshot, we can just ignore these parts, doesn't really matter. But this part is important because at the end of the day, we want to have all those changes in Kafka as JSON. Just remember, in database, we have schemas, and basically we have data types for different columns. We don't have such a thing in Kafka, right? At the end of the day, all those data are gonna be inserted in Kafka as text, right? But here we just instructed that we want it to be as a JSON. So we have, in nested JSON, we will see the messages, including, let's say, keys and values mapped to a specific columns and rows. We will see it in action. So basically these two are super important. We want to have all of them like as a JSON in the Kafka. And yeah, these are also not that much important. We can talk about it, we can discuss about it, but it's more advanced thingy, I think. Most specifically this one. And also this one. So anyhow, so this is the CR for the Kafka connector. You see this kind is Kafka connector, and then it will just interact, and creation of the Kafka connector, creation of the Kafka, creation of the Kafka Connect, all of them are on operator shoulders. So we just deploy the application, back off, and wait for everything be up and ready. Let's do it right now. So I will create a new application here. Let's say Kafka N for one thing, and then here, and then namespace and the head, and then it is lab-kafka-connect /applications/Kafka, if I'm not mistaken. So yeah, overview CD, and we are good to go. Good. So yeah, let's have it synced and see what exactly is going on. Shazam, operator kicked in, right? As soon as we apply the CR, operator kicked in and starts just provisioning the Kafka clusters and so on and so forth. You see all of these things. Kafka Connect cluster is forming with 3 nodes because we just specified 3. And yeah, then let's just wait for it. Why wait? Let's see what exactly is happening. Kubernetes Kafka, okay, get peel. So we already have a Zookeeper cluster being created. Let's wait for it. It's downloading right now. So let's wait for it. So you see this Kafka connector, Kafka Connect cluster is actually failing, and the reason is quite obvious because we don't have Kafka cluster up and running yet, right? We need to have to wait for Zookeeper to be up, and after Zookeeper is up, basically Strimzi will just provision the Kafka itself and just connect it to the Zookeeper, and then Kafka Connect is healthy and can work. Let's wait for it a bit. Okay, we have here Zookeeper running. Very good. Okay, get PO. Okay, likes-f. This is just bootstrapping process, so you have to be patient a bit. Let's be patient. Okay. As soon as we have Zookeeper up and running here, you see that Kafka first node is actually just being provisioned right now. So, okay, get PO. It's running, just waiting to establish the connection to the Zookeeper and everything. And yes, it is up and running, both of them, right? Now it's time to have the, let's say, Kafka Connect cluster up and running. Just give it a second, it will just try several times, and after that, okay, the first node is actually running. Let's see. The second node is running, and just imagine, we just provisioned the CR, and that's the beauty of this Strimzi operator. Everything is being handled by operator itself, everything. And everything is actually Kubernetes native. That's amazing benefit. Okay, we have all of them up and running, but none of them still is healthy. So let's wait for it a bit. Oh, and another thing, because all of this is actually we can use this time to check another thing, because everything is actually based on the CRs. So basically, you have new Kubernetes objects using Strimzi operator. So if I run kubectl get, for example, Kafka, I shall see the Kafka clusters I have. I mean, it has only one, and then only one zookeeper, and it's ready. If I get for Kafka Connect, I shall see the name of the Kafka Connect cluster. I mean, this is the desired replica, and the status is not ready. So the ready is not true yet. If I get for Kafka Connector, for example, I shall see this one, the Debezium Postgresql. It is inside my Connect cluster, Kafka Connect cluster. This is the class, this is the number of the task, and it's not ready yet. So you see, using the Strimzi, you can just see whatever definition you have. You can even edit it. So for example, edit, let's say, edit Kafka for one thing. This is the definition of the Kafka you have. You can just simply bump the version right here, or just create a PR for it, merge it to the branch, and then Argo CD will take care of it as well, and so on and so forth. Okay, now we have all these things up and running again. We can also see this as, let's say, get Kafka Connect cluster, and it just changed to ready, and so on and so forth. Very good. Now let's connect to the Postgres database that we already created, right? Let me just bring up the pgadmin. So I would go for, let's say, what's going on? So I will just give it a refresh. Very good. This is the database that we already created. This is the publication that I was talking about. This is the tables. So basically, if you check the README file created in the repository, you shall see. That's the point. I mean, I just created a table, namely employee, just like by 3 columns. One of them is just like primary key for ID, and 2 random, I would say, string thing. It doesn't really matter. This table will be targeted by the load generator we created. So when I run the load generator, it will just target this table and just bombard it with lots of, let's say, information. Lots of data, sorry. And yeah, this is it. Okay, the publication. Let's see what do we have the publication, by the publication here. So the publication is already created by the Strimzi itself, and I just named it like Kafka_Connect. I mean, this is in the definition of the CR if you check it. So the name of the publication is Kafka_Connect. By default, Debezium connector will create it as all tables, right? This is very important thing. Be careful, because there might be some cases that you don't want this specific publication being created by Debezium connector itself and set as all tables, because you shall have some tables in your database that you don't really want to be streamed, because these data are not that much in your interest or something like that. Or maybe you have some tables, that's the big issue, without primary key. I know it's not the best practice, I know, I mean, you cannot probably even conceive that, but that happens. I mean, maybe in the past, some developers just create a database, for example, with like no primary key. And if you go with the all tables, what connector does is just like by, not connector itself, by the Postgres itself, it's just like by creating the index out of the full row of that table, right? That is not good, because it has an effect on the performance. That's one thing. The second thing is just like you cannot simply delete from that database as well, because this is the mechanism of Postgres. If you have a table that is indexed by the full row, you cannot delete on that. So just keep that in mind. But in general, you shall also see the options. Do you remember I mentioned that you instruct that logical replication slot? What changes should we consider? That's here. We just said that insert is important for us, update is important for us, and delete is important for us, and truncate as well is important for us. So basically everything that might happen in the table in Postgres is important to us. If you are not that much fan of just keeping track of delete, you can just disable it. You don't want to get the updates, disable it, but this is the original configuration of it. And for time being, let's say employee, what do we have in the employee? I hope it's a let's say empty one. Yes, it is empty one. It only has like 3 columns, right? The ID, the name, and the family. And the name and the family is supposed to be generated by the load generator we created in Go language. We shall see it very quickly. But this is it. And then what? Okay, we just saw the publications, right? The table in the Postgres. So everything Postgres side is a go. We can just leave it alone. Let's focus on the Kafka itself. So yeah. For understanding what exactly is happening in Kafka, I will just get the pod. I would say Kafka UI is up and running, right? So as mentioned, I just placed Kafka UI because I want to see what is happening in the Kafka in graphical mode, not just like, console. So let's connect to it. Yeah. So basically in the deployment, it will come up with, let's say, one service. I will just bind my local port 9595 to 8080 of the Kafka UI. Okay, and then let's go back here, 9595. You shall see your, let's say, cluster, Kafka cluster here. It's on version 3.8. Number of the brokers, number of the partitions, number of the topics, and so on and so forth. So if we go to the topics, we shall see these configuration topics, internal configuration topics. These 3 are for connectors. So basically, this is the way that Kafka Connect cluster basically, can keep track of what exactly is happening in the whole system. Where is the task for the Debezium connector, until which part it has just streamed the data, and so on and so forth. So these are actually internal and configuration topics. But you already remember that I mentioned we have a mapping between the tables and the topics here, right? We already have a table, default employee in the Postgres, but we don't have any topic for employee, right? Why is that? The reason is like the table is empty and nothing has happened in that table. That is the reason, right? So basically, as long as there is no change on that specific table, it's not being tracked and it's not being streamed. As soon as you have one single, let's say, insert into that table, then that is the time that actually you shall see the topic is being created and then the messages. Let's see it in action. So what I'm gonna do is, let's say, coming back here. Okay, I will try to leverage the load generator I created for just inserting lots of rows in the table. So where do I have it? If I go to load generator, this is very simple Go application, just like connect to the database and target a specific, let's say, table, which in our case is just like employee, and just generate 2 random strings as a name and the family, and just insert it. That it is. So let's say go run load test generator. Okay. You shall see it just like inserting this amount of data, this amount of records in the database. If I check this part out. Now if I run it, I shall see that, I mean, there are some records. For example, this is the number of the records, and then if I just run it again, you know, it's just increasing, right? My expectation right now is just like having the topic created in the Kafka as well, and that topic should basically have the exact same amount of messages. So every row insert in table should correspond to one message in that specific topic. Let's see. You see, the topic is already created and it has already this amount of messages inside it, and it's increasing very real time, just like what we experience in the database. Let's, for the final stage, just check one of the messages for one thing. If we go to the messages, let's say any of them, doesn't really matter. So if we check it, this is the schema of the table. You remember that we use JSON converter for the type of the, I mean the configuration of the connector on the Kafka Connect. This is it. So basically we have ID. Let's check it together. We have ID. It is integer. So basically it detects that it's integer 32. We have name with the type of a string. We have family with the name of the type of the script. A string. That's the beauty of the whole system. So basically it mapped the whole schema you have there using structs, but in JSON format form, right? This is crucial because when another connector, like for example BigQuery connector, wants to just ingest this data and send it to BigQuery, it knows exactly what schema in BigQuery should be created, what columns with which types. That's very important. But what about the messages itself? If you scroll down, you shall have, let me just find it. You shall have the payload. You see, inside the payload, you have before, after. Another beauty of this system. So basically this is the CDC system, right? Capture data changes, right? So basically you may want to know, for example, if you have a delete change in your table, basically the after gonna be empty, right? Because after deleting you have nothing. But before should be the data that you had before deleting that specific row, right? So in here we have before as null because it's just like fresh insert, and then for the after we have the ID, the value, the name, and the family, just like whatever we have in database in that table's rows. Okay, I think it's enough. I will just stop the load generator because it's just bombarding my whole system. But yeah, this was the whole concept. You just saw that how exactly can we have all the data streamed in from Postgres to Kafka, and then from Kafka to another system you need another connector. The whole mechanism is just like what you saw. You just have to define the new connector and just run it, and that it is. And after that, the secondary connector is responsible to just ingest all those, all these messages available in the Kafka as a consumer, and just send it to another system, a data warehouse, a MongoDB, I mean, in a Google bucket, in any bucket, doesn't really matter, whatever destination that you need, right? The benefits of this system is just like, it's real time, or let's say semi-real time. I mean, it's super fast. I mean, way faster than just generating reports as a batch, sorry, not batch, as a batch and something like that once per day and so on and so forth. You can see all the changes in action. You can see all the changes reflected to a destination in a real time or very small margin of time. And yeah, that was it. All in all, it's super beautiful thingy and super amazing thingy because when you see it in action in production environment, you shall see terabytes of data, just flying from here to there, and then that's amazing. That's amazing. In the next video, we will take care of providing enough monitoring for this system. So not only you shall see the messages like what we see here, but you also will see the CPU utilization of the connectors, the number of the connectors, the behavior of the disk I/O, the behavior of the network I/O, and so on and so forth. So basically, you will gain a full observation over these connectors and understand what exactly is going on. Thank you very much for bearing with me. If you find it useful, please give this video a like and also do the subscription. The channel is super young. I mean, I literally need it for just having a growth in the channel. That's one thingy. Yeah, please stay tuned for the next video. Bye bye.